Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, today we are going to start a new chapter, that is a motion in one dimension. Dear children, before going to start our lecture, let us see the scope of the chapter. Under this motion 1D, what are we going to discuss? Dear children, here in motion 1D, we have three subunits we have. In the first unit, we will be discussing the basic concept related to the motion 1D. There we will be discussing about the types of physical quantities. There we will discuss what are scalars, vectors. Under that, we are going to discuss about distance, speed, and displacement, velocity, acceleration, and acceleration due to gravity. Whereas in a unit B, we are going to learn how can we represent the one-dimensional motion graphically. Displacement versus time, velocity versus time, acceleration versus time. So those are the things, means what are the concepts which we are learning in a unit A, we are going to discuss in detail in a unit B with the help of graphs. Whereas come to the unit C, it is all about equations of motion. How the physical quantities in a one dimension are related. Velocity, that is the initial velocity, final velocity, distance traveled, acceleration, time, these all are how they are going to be related. Those are the things which we are going to discuss in a unit C. So in today's session particularly, as I said that just we are going to start a motion 1D, there we will discuss the topics from unit A. Children, before going to discuss what actually motion 1D, let us recall once again what is physical quantity. Dear children, about this physical quantity, we have learnt already in what are measurements and experimentation. Just let us recall what actually physical quantity is. So the quantity which is measurable, means the measurable quantities are called physical quantities. For suppose feelings, love, like, angry, hungry, do we measure these things? No, we cannot measure. So these things are not physical quantities. Whereas come to the height, weight, speed, velocity, acceleration, force. So these are the things, these are the quantities which are measurable. So such type of quantities only we can call it as a physical quantities. I repeat once again, the quantities which are measurable are called physical quantities. So in that what we can say measurements and experimentation chapter, based on whether quantities depend on other quantities or not. Okay, based on that, physical quantities are classified into two groups. There we discuss about fundamental quantities and derived quantities. But in this chapter, dear children, again we are going to have one more classification of physical quantities only, not based on whether they are dependent or not. Rather, it is based on whether direction is needed in order to explain a physical quantities or not. So first of all, dear children, if you want to understand this type of physical quantities, first we should know the importance of direction, whether direction is required or not. For suppose, dear children, somebody, if you want to ask height of some person, what do you ask? Excuse me, what is your height? So if they will say either 150 centimeters, 160 centimeters or some 5.6 feet, what it may be, don't you think that information is enough? Yes, that 150 centimeters or 160 centimeters information is enough to explain about the height of the person. Then you cannot ask, okay, your height is 160 centimeters. Then can you please tell me what is your height in a west direction? What is your height in a north direction? What is that? Asking time in a north direction, west direction? No, it is not at all correct even. Okay, and let us take one more situation where you are standing near a bus stop. Then you are waiting for a bus and you want to know the time, you don't have watch, even cell phone also you don't have. Just let us think. There one person is standing. So generally what do we ask? We ask, excuse me sir, what is the time now? That is enough. Then the person also will respond properly. You will come to another time. If not, just take a situation where you will ask like this, sir, excuse me sir, can you please time in a north direction? Can you please tell in a time, can you please tell a time in a south direction? What is that? If you ask, excuse me, can you please tell the time in a north direction or west direction, the person will sit top to bottom. They will think, pagal hai kya? What happened? What are you asking? You want a time means you can ask, but what is this west direction, north direction? So dear children, their direction is not needed. So what I mean to say is that here, in order to talk, in order to explain about a certain physical quantities, direction is not needed. How much? For that it is enough. Height 10 centimeters. Enough it is. Time 8 o'clock, 9 o'clock, 10 o'clock, it is enough. So, for certain physical quantities, direction is not needed. Then where we can, where this direction is important? Where this direction? First of all, is direction important? That is a question. For example, dear children, so there will be a radio announcement by a radio jockey, let us say, regarding, but he is saying that, dear Hyderabad is, there will be a, like, tsunami, means, I mean, of course, there is no ocean, no chance of tsunami only. Just let us imagine a situation, take it just example. So there is a tsunami is going to attack the Hyderabad. Just you please be careful and just run away from the Hyderabad, then you can survive it, like you can save your lives. Like that he said. And just after that, the connection was disconnected. Just you think. And he said that tsunami is coming. Even he gave one more information by saying that tsunami is going to hit the Hyderabad with 150 km per hour or 200 km per hour. Just example, children. It's not, don't take serious. Just example. Then okay. Then in that hurry, just what we'll think, we'll try to take a few things and we'll try to run. But we'll get one doubt. The fellow said that 150 kilometers per hour, he said. But he did not say in which direction it is coming. In which direction? Now we will be in dilemma. Should we run towards south? Should we run towards north? Should we run towards west? We don't know. If you run towards west, if it will come from that side only, so we will be in dilemma. So in that case, dear children, so saying the speed, with what speed it is coming, along with that, direction also you must say is very, very, very important. Very means very much important. So not only that. So there will be a function, just you think, where you want to attend some your marriage, like your a friend marriage function you want to attend. And your friend just, he sent information through, like, it's like post, let us say. You don't have like any phone or any other device to communicate, let us think. He said that, my dear buddy, you must attend my marriage. And moreover, it's very, very close to your house. It is just 4 kilometers from your house, he said. Okay, by seeing that information, you felt very happy and you are very, next day, you are ready to go to that marriage. Okay, then after everything, then you are ready to go and, you are completely ready to attend the marriage and everything. Just after coming out of the house, just one more doubt will come into your mind. My buddy said that 4 kilometers from my house. That is fine, I know what is the distance from my house. But which direction should I go 4 kilometers? So almost 360 degrees possible 4 kilometers means. So without knowing the direction, dear children, can you get the that address, or can you think that the whatever the information is given by your friend is completed? It is not that. So just see, what I am trying to say is that here, try to understand the importance of direction. Means direction is not compulsory in all cases, and some cases direction is compulsory. Direction is compulsory. So based on direction, even dear children. Let us take in terms of physics, let us take one example. Somebody will ask you to apply 10 newtons of force on object. 10 newtons of force on object. And it is a very important, 10 newtons is okay. How much? It is a 10 newton. But in which direction is very, very important. In which direction? Because depends on the direction, what will happen, the object is shifted. So you cannot say that 10 newtons of force is like, what are the 10 newtons of force acting is always similar. It's not that. For example, dear children, here, let us take it as one object is there. If force will act in this direction, the body will move like this. If force will act in this direction, the body will move in this direction. Means the effect will be different. The result will be different. The conclusion, the climax will be different actually. So, in some cases, direction is very, very important. So, based on that, whether physical quantities dependent on direction or not, they are classified into two groups. So here, one group is called actually scalars. So what are scalars, dear children? The physical quantities which have only magnitude. Means their direction is not important. Direction is not required at all. Such type of quantities only we can call it as scalar quantities. For example, as we spoke about time, let us take. So to describe about time, dear children, direction is not important, and even mass, direction is not important. You can take a distance, as I said, let us take height is a distance only. So here distance comes under scalar group only. Even speed also scalar quantity only. And even you can take a work, power, energy, many things are there. So these are the quantities, these are the physical quantities which have only magnitude. Here direction is not important. Whereas when you come to the vector, then what are vectors, dear children? The physical quantities which have both magnitude and as well as direction are called actually vector quantities. Children, I repeat, scalars need only magnitude, but whereas vectors need direction and as well as magnitude. Children, here let us see the one example. So here for example force, let us take here is displacement, then velocity, displacement, and here is velocity. Then you can take a force, acceleration, many things will come. So let me write even here current also. Let me write here current also. So there will be a little bit confusion about current actually. So children, what is a vector? A physical quantity should have a magnitude and as well as direction. Now for example, let me take here is wire, is a point A and is point B. So through this from A to B, 20 amperes current is flowing, 20 amperes current is flowing. So now let us check whether current has direction or not. Of course, it is going from A to B. Obviously, current has direction, but how much? 20 amperes. So it has a magnitude. But one very important thing, can we say that with that, can we say that electric current comes under vector quantities only? Of course, what is the information which we have from the definition of vector? We must take electric current as a vector only. But dear children, though electric current has magnitude and direction, it is not a vector quantity. That's what here there will be question mark, which means what? Along with the direction and magnitude, some other information is needed in order to decide whether quantity is a vector quantity or scalar quantity. So what is that? It also should obey the laws of vector addition. Very important. Laws of vector addition. Laws of vector addition. So regarding this laws of vector addition, in a higher classes we will be learning in detail. So now, in order to check whether one physical quantity is a scalar or vector, children, or else I can say that. So in order to decide whether it is scalar, you can check if direction is not there, then it comes under scalar family only. But in order to decide whether given quantity is a vector, then what we have to do here? We have to check these three things. Should have a magnitude, of course. Should have a direction, yes. Along with that even, it should obey the laws of vector addition. So such type of quantities only we can call it as a vector quantities. So children, finally, what are scalar quantities? The physical quantities which have only magnitude but no direction are called scalar quantities. Comes to the vector quantities, the physical quantities which have both magnitude and direction and as well as should obey the laws of vector addition. So this is all about scalars and vectors. Now we will discuss a few more terms like a basic terms related to our discussion, children. So here, what is a rest and what is a motion? And how both are related? When you can say that a body is at rest, when you can say that a body is in motion. Dear children, so if you want to discuss when a body is at rest or when a body is in motion, we need one reference point. So without reference point we cannot. Means you need some with respect to some x or some y, some z only, you can say that whether body is at rest or body is in motion. For suppose, first of all, what is a rest, dear children? So when you can say that a body is at rest. Dear children, when a body is not changing its position with respect to its surroundings. With respect to its surroundings. For example, my body is fixed to this wall. Fixed to this wall. For example, from that wall, from that another wall, it is, for example, let us say 2 meters distance. So today it is at 2 meters only from that wall. Tomorrow, day after tomorrow, so like that only. It is always 2 meters. Means this board is not changing its position with respect to the wall. Then I can say that the wall is at rest. So when a body is not changing its position with respect to the surroundings, then we can say that a body is at rest. Then what is a motion? When you can say that bodies are in motion. So when a body is changing its position continuously with respect to the surroundings, then we can say that a body is in motion. But how rest and motion related? Children, actually, in fact, Rest and motion both are relative terms. It's too difficult to say body is at rest completely. You cannot say that. You cannot say that a body is at body in motion completely. It's not that. So in order to understand that, in order to have more clarity, let us take a small example here. So here one person A is like a standing at what we can near this tree, and here two persons are going like in a car. They are going in this direction. So direction also shown here. And the very important thing is, dear children, with respect to the person C, with respect to, so our question mark is that here our question is that what about person B, whether person B is at rest or in motion. So children, actually person B can be at rest, can be in motion. Then you may doubt, sir, how it is possible? A same object, how it can be like a rest or a motion at the same time? It is possible. That's what I said. It depends on what here surroundings. With respect to what? What is that reference point? With what respect point you are trying to describe its position or describe its motion is very important. For suppose, dear children, with respect to the person C, let us see here. With respect to the driver, this person B is sitting. Of course, entire car is moving. I am not talking about car here. Just I am talking about only person B with respect to the person C. Of course, as long as they continue journey, definitely almost their distance is fixed. Means he won't move. So here, with respect to the person C, or else with respect to the compartment of this car, with respect to the compartment of that car, the person B is not changing its position. So we can say that the person B is at rest, but with respect to person C, very important, with respect to person C or car. I think that the compartment of the car is there. So with respect to that, we can say that person B is at rest only. But what do you think about with respect to person A? So person A feels that the person is going. Why? So this distance from here, initially it might be 10 meters. Do you think that it will be 10 meters always? No. 15 meters, 20 meters. So that will be increased. Means I mean to say that is changing. The position of the person who is sitting in the car is changing with respect to the person A. So here the person B is in motion here with respect to person A. With respect to person A, or you can say with respect to even tree also. So here the person B is at rest and person B is in motion, means at the same time it is possible. That's what I am saying. So with respect to what is very important. So a body, if you can take any body, it can be at rest, it can be in motion at the same time. It depends on with what respect to you are trying to describe. So children, what is a rest? When you can say that a body is at rest, a body is not changing its position with respect to the surroundings, then you can say that body is at rest. Then what can you say about a motion? If any object is changing, its position with respect to the surroundings, then you can say that that body is in motion. Okay children, fine. Now one very important thing, let us think. Let us talk about motion only. Okay, we are discussing motion. So what is a motion? The body is changing its position. That's it. You fix. Children, throughout chapter you have to fix one important thing. What is that? Objects are not at all rest. All objects are moving only. But how they are moving is very important. How they are moving. So means along which path they are going. Let us discuss one. So before that, dear children, so let us try to understand here. Try to understand actually what is our meaning of our chapter name. Our chapter name itself is a motion in one dimension. So try to understand what is this one dimensional motion. So children, for example, in order to understand this, let us take a small example. So here is a straight line road. So you can take any object. Either it's not compulsory always to take a car. You can take any object. So if this object is going along a straight line path, if it is going along a straight line path, such type of motion we can call it as a linear motion in simple terms, or we also call it as a rectilinear motion. In more effective manner we can say that one dimensional motion. So children, if any object, so here straight line path is very important. It is here straight line path. So straight path, this is very important. So if any object is going along a straight line path, it is said to be in linear motion or rectilinear motion. You can say it as a linear motion or one dimensional. 1D means what? One dimensional motion, or even you can say that rectilinear motion also. Example means you can take any object if it is going along a straight line path. So it's very important. There is no change in direction. Always all bodies are going along a straight line path. Then you can see that those all bodies comes under what type of motion? Linear motion or one dimensional motion. That is fine. Means these children here very important thing. So if you can take a XYZ coordinate system, for example here, let us say, or else for this one let us take here y take separately. So this is, let us say, it's x-axis, okay, and this is going to be y-axis, and this is z-axis, so that it is origin. So with origin the car position is changing, so that it is in motion, that too along a straight line path. Children, here if you can see in this, during this motion here, take x coordinate, y coordinate, z coordinates. So don't you think that only x coordinate will change, because the body is going like straight line path only. So there is no chance of changing either y coordinates or z coordinates. Only x coordinate will change. So for a sudden, for example, it is a 2 meters distance from origin. So this we can represent 2, 0, 0. So there is no change in either y coordinates or z coordinate. Means only one coordinate, value of one coordinate only will change during what we can say linear motion or one dimensional motion. Children, very important. Just try to highlight this one dimensional motion. Okay, fine. Now let us take one more type of motion, children. For suppose whenever we are playing a carom board, or else whenever you are playing billiard games, there did you notice the motion of that ball or a coin when we hit with another coin or when we hit with that cue? What happens here? See, for suppose let us take, here is that board actually, this is the board, let us take here, and here is that particular ball. Let us take either coin or a particular ball. Okay, now so when you hit, it may move in this like this. For suppose like this it is going, like that is going. Just try to think. Now here let us take, here is, it is x-axis, and this is going to be, it's a y-axis, and here is a obviously z-axis. Am I clear? So this is a plane of board, children. Now of course in our discussion that is a board plane of board actually. Okay, now if you can think here, what will happen, as it is moving like this, dear children, so it is covering some distance on x-axis as well as it is covering some distance on even y-axis also. Means here x coordinate and y coordinate both are going to be changed, but not z, value. So here you can take some like 2 meter distance from x-axis, 4 meter distance from y-axis, but z is 0 only. So such type of motion means the motion of any object in a plane, any object in a plane is considered as a two-dimensional motion. Children, it's very important. So in two-dimensional motion, what will happen? X coordinate, y coordinate will change, but not z coordinate. Example, I said the motion of a carom board coin in that board, in that plane of board, and even motion of a billiard ball, anything is okay. For example, you are in a room. Normally you are walking, of course in that plane also, in special case we can consider as a two-dimensional motion, unless you are walking only along a straight line path. That's very important. Okay, fine. Now, so here two coordinates are changing. Now let us see here one more type. It's very important. For suppose, dear children, just imagine a situation where let us take an example of our room only, especially corner. Let us take corner. So how the corner will be, dear children? For a room corner, so this is what actually, if it is like this and some corner, it will be like this, let us say. So three corner, point of corner. So this will be wall again. Here is one more wall. Now just imagine a situation at this point, at a near corner. Okay, now one mosquito or one insect is there. It is moving. Achha, just imagine it is moving diagonally. To that room. It's very important. So for a room, just take the diagonal. For along the diagonal, one insect is going. Means it is completely about space. It's like a three-dimensional space it is, where x coordinate, y coordinate, z coordinates will change. So it is x, it is y, let us say, it is z here. So it is origin. Means here children. So for example, it might be 2 meters from x distance, 3 meters from y distance, 5 meters from dash distance. Means here in the space, means the motion of object in a space is considered as a three-dimensional motion. Three-dimensional motion. Children, in a one-dimensional motion, only one coordinate will change. Either x, either y, either z. If you can take horizon, it depends whether you are taking a motion of object along x-axis, y-axis, z-axis. So in a two-dimensional motion, two coordinates will change, either xy, yz or zx. Whereas in a three-dimensional motion, dear children, three coordinates will change. So then what is a one-dimensional motion? The motion of an object along a straight line path is called one-dimensional motion. The motion of any object in a plane is taken as a two-dimensional motion. The motion of any object in a space, given space, is considered as a three-dimensional motion. But dear children, in our chapter, what is our chapter name? Motion in 1D. So we are not going to discuss about three-dimensional motion. We are not going to discuss about two-dimensional motion. Just we are going to discuss about only one-dimensional motion. I mean, dear children, throughout chapter, every time we are not going to repeat the body is going along a straight line path, straight line path. It's not that. You have to keep in your mind. By keeping the very important thing in our mind, what is that? The body through chapter from the beginning to ending, almost in all cases, will be taking aware objects are going along a straight line path only. Then we will be observing how the velocity is changing, how the acceleration is changing, how the displacement is changing. So, and we will be calculating those values. We will be calculating those values. So, children, this is just introduction part of or a chapter of motion one dimension. Here just we discussed only two things only we discussed. We discussed about types of physical quantities, then we discussed about water scalars and water vectors. Then we discussed types of motions, one dimensional motion, two dimensional motion, three dimensional motion. But dear children, for us only one dimensional motion is very, very important. So in next session, we are going to discuss about the differences between distance and displacement and how they are going to be related also even. And after that, we will discuss the change in distance, change in displacement, so called speed and velocity. Finally, we will end this unit in a next class with a concept called acceleration due to gravity. But dear children, so listening class is not important. You have to go through the textbook. You have to read. And one more very important, dear children. So whenever you are reading a textbook, keep one more notes aside. And try to make a point, try to note an important point, which means what? Try to make your own notes. It's very, very, very important. It's not like a depending on guides, depending on others. It's not that. The first thing is, fundamental thing is that textbook is the first priority. Give first priority textbook. After that, you have to make your own notes. So that what will happen? You can remember what we can say concept for a long time and there is a less chance to forget. Okay, children. Thank you so much. All the very best.